was the altitude correction. We saw all the corrections and we understood that instead of the individual correction, we can apply the total correction now. And then we were seeing all these corrections one by one. Index error is given to us in the question, dip correction obtained from the first page of the almanac. And now we will be looking at total correction. How do we obtain the total correction? So let's proceed. Dip correction table was seen. Let's move to the total correction now.
Now, after the dip correction, the next correction which we require is the total correction. So let us now see the total correction for all celestial bodies one by one. As I told you, we have 4 celestial objects, celestial bodies available to us. That is the sun, the stars, the planets, and the moon. So let's open up the first page of the almanac once again, the same page which we saw in the previous slide. Now you can see the total correction for the sun. Let's first find out it for sun. You can see the total correction for the sun given on the left hand side in the first table. So you see the table which is highlighted. It gives you the total correction for the sun. The table is entered with apparent altitude as well as the limb of the sun. So you enter with the apparent altitude. There are 2 corrections given against each apparent altitude, or for a range of apparent altitudes, 2 corrections are given. The first correction is for the lower limb of the sun, and you can see a positive sign in front of it. And the second column gives you the correction for the upper limb of the sun. You can see a negative sign for the upper limb total correction. Now, one more thing which you will observe here is that the total correction table of the sun is divided into 2 parts. The first part of the table gives you the total correction for the period between October to March. And the second part of the table gives you the correction between April to September. So basis the date on which you have taken the site, you will be entering the appropriate part of the total correction table. Check the date for which what is given in the question on which the site is taken, and basis that date you enter into the appropriate part. Enter with apparent altitude. Out of these 2 corrections, pick up the correction for the limb which is given in the question. Lower limb corrections are positive, upper limb corrections are negative. Now moving to the second celestial body, that is the stars, and the next one, that is the planets. Now for stars and planets, we have a single table. The second table which you see on the first page of the almanac gives you the total correction for stars as well as planets. This table is also entered with apparent altitude. So you enter with the apparent altitude, and for a range of apparent altitude, the total correction value is given here. All the total correction values are negative. So the second table gives you the total correction for stars as well as planets. Now, when you are picking up the total correction for planets, you have to be careful about 2 planets, that is Venus and Mars. Now, whenever the altitude correction is being done for Venus and Mars, once you have referred to the total correction table, obtained the total correction against the apparent altitude, after that you have to apply an additional correction also. You see the additional correction value is mentioned here. in the second part of the table, this additional correction also has to be applied to these two planets, that is Venus and Mars. Now, how is this correction applied? You can see for every planet, say for Venus, they will give you a range of dates. The first part they have given January 1 to December 10. The apparent altitude between 0 to 60, the correction is plus 0.1 minutes. Then in the second part, they say December 11 to December 31. From 0 to 41 degree apparent altitude, the correction is plus 0.2. For 41 to 76 degree apparent altitude, the correction is plus 0.1 minutes. So the correction has to be picked up from the second part of the table, the additional correction, and the additional correction has to be applied in addition to the total correction obtained from the total correction table against the apparent altitude of the body. Now, important thing to understand here is this additional correction, as is clear from the name, is additional to the normal correction. The normal correction given on the left-hand side part of the table against a range of apparent altitudes. The additional correction is over and above the normal correction. Please don't forget to apply the normal correction. It should not happen that you apply only the additional correction and you forget about the main correction. So it is applicable only in the case of Venus and Mars. Now a doubt may arise in your mind. What is this additional correction for? Now basically Venus and Mars are closer to us compared to Jupiter and Saturn, which are the other two planets used for celestial navigation. Being closer to us, they appear slightly bigger, and just like Moon, it is possible that they may be showing phases. You may not be able to see the complete planet, but you may be able to see some part of the planet, just like you can see the phases of the moon. Sometime you see the full moon, sometime you see a gibbous moon, sometime a crescent moon. So that way there could be this phase effect with these two planets also. And other than the phase effect, these planets are very close to us. So they have a substantial parallax, which is a positive correction. The parallax of these planets could also be substantial. There is no parallax for Jupiter and Saturn. They are too far away from us. So the radius of the Earth does not subtend a suitable angle. But for Venus and Mars, there could be a little bit of parallax. So this additional correction takes care of both these small corrections, that is the phase correction and the parallax correction. These are not applicable to Jupiter and Saturn as they are far away, they do not show the phases, and they do not have any parallax. They are not applicable to the stars either, because stars have their own light, they emit their own light, so they don't show any phases. And secondly, stars are so far away that parallax for stars is nil. So this was the total correction for the sun, for the stars, and for the planets.
Beta, all clear up to here? Any doubts anywhere till now?
No, sir.
No, sir.
Okay, very good. Let's proceed ahead.
Excuse me, sir.
Bolo beta.
Sir, in dip for height of 5, we are taking direction which is on the upper side of the direction. So similarly, in this one also we'll do.
नहीं बेटा, अपर वाली करेक्शन तब लेते हैं जब क्रिटिकल एंट्री आती है. गिव मी एनी हाइट ऑफ आई up to, let's say, 22 meters. Any height of I?
6.5, sir.
Okay.
2.5.
6.5. Okay.
Yeah.
Okay. Now, if you look at this table, beta, the dip correction table, You see 6.5 lies between these two values, 6.3 and 6.6, correct?
Yes.
So in between these two, the entry would be minus 4.5.
नहीं सर, आई मीन मतलब वो पूछ रहा है कि 6.6 पे भी 4.5 लेंगे ना?
राइट, अगर क्रिटिकल एंट्री आ जाती है, दैट इज 6.6 आ जाती है, वी टेक द अपर वैल्यू, दैट इज माइनस 4.5 ओनली. 6.7 हो जाएगा तो माइनस 4.6 आ जाएगा.
तो सर अपरेंट ऑल्टीट्यूड में भी सेम करना.
Okay, yeah, you can do the same thing in the apparent altitude also.
Okay.
Okay, but it is very rare that you will get a apparent altitude. Haven't seen it in any question till now, the apparent altitude matching exactly with these figures. But yes, if it matches, you can take the upper value.
Got it, sir.
Okay. Or beta, any other doubt? Okay, great. Let's proceed ahead then.
Let's now see the total correction for the moon. Now, moon is the celestial body which is nearest to us, the nearest celestial body. The more closer a celestial body to us, the more complicated its apparent motion becomes. So you will see that all the things associated with moon are slightly more detailed, slightly more complicated as compared to sun or the stars or the planets. The total correction for the moon is given on the last page of the almanac, and it extends to 2 pages. You can see the last page of the almanac now giving the altitude correction for the moon. Now this total correction table is divided into 2 parts. You see the upper part of the table, which gives you the main correction, and you see the lower part of the table, which gives you the HP correction. What is this HP? HP is the horizontal parallax. This is the parallax of the moon when the moon is on the horizon of the observer. So let us see both these tables one by one. Let's zoom into these tables, the upper one and the lower one, and see how these tables are referred to. You can see the upper part of the table now. Now this upper part of the table, which gives us the main correction, is entered from top using the apparent altitude. So apparent altitude has already been obtained by applying index error and dip correction. So you enter into the top part with the apparent altitude. You can see every column gives you a range of 5 degrees of apparent altitude. So from 0 to 4 degree 59 minutes, then 5 degrees to 9:59, then 10 to 14:59, 15 to 19:59, and so on. Depending upon what your apparent altitude is, you enter into one of these columns and you pick up the main correction from this part, upper part of the table. Let's say, for example, your apparent altitude was 3 degrees and 50 minutes. So you will be entering into the first column. You see 0 degrees, then 1 degree, 2 degree, 3 degrees. And then on the side, you can see the minutes, 0 minutes, 10, 20, 30, 40. So for 3 degree 50 minutes, the correction is here, which is 56.1 minutes. So this is how you obtain the main correction. There is a dip correction table given here alongside, but this dip correction table is little shortened. So I would recommend you use the table given on the first page. It is not that this dip correction table is applicable for moon. Dip correction has got nothing to do with the celestial body. Dip correction depends only on the height of eye of the observer, and it is the same for all celestial bodies. So you can refer to the dip correction table given on the first page itself uh, for the moon's dip also. Now let's see the bottom part of the table. You can see the bottom part of the table here. The same column which you entered from top, you go down into the same column for picking up the HP correction in the bottom part. Now, when you enter into the bottom part, you will see two columns, two sub-columns in every one column of the upper table. One is represented by L and another is represented by U. It stands for the lower limb and the upper limb of the moon. So depending upon whether the altitude is of the lower limb or the altitude is of the upper limb, you will enter into one particular part. And when you come down, you will see on the sides, the HP values, horizontal parallax values of the moon are mentioned. So when you come to this part of the table, first you find out whether it is upper limb or lower limb. Let's assume in our particular case, it was a lower limb observation. So you enter into the L part of the column and then you look for the HP of the moon, which was there at the time of the sight. Now, how can we find out the HP of the moon? The HP or the horizontal parallax of the moon is given in the almanac for each and every hour of the year. So once I go to the daily page of the almanac, I will show you the HP value there. So this horizontal parallax is picked up from the daily pages, the date pages of the almanac for the date on which the sight was taken, for the hour for which the sight was taken. So let's assume in this case the HP was 54.3 minutes. So you can see for the lower limb and for a HP of 54.3, the HP correction is 0.7 minutes. So you have obtained the upper correction, which was 56.1 minutes. You have obtained the HP correction, which was 0.7 minutes. Now both these corrections are positive. Both these corrections are positive. They have to be added up. Now once you add up, after that one more thing has to be seen. If it was a lower limb observation, the altitude was of the lower limb, you add these two corrections and you will obtain the true altitude of the moon, or you will obtain the total correction for the moon. But in case if this was the upper limb of the moon, then you have to subtract 30 minutes in the end. You can call it a upper limb correction, and 30 minutes have to be subtracted from the altitude of the upper limb to obtain the true altitude of the body. So to summarize, you get the main correction from the top part of the table. You get the HP correction from the bottom part of the table. Both these corrections are positive. If it is a lower limb observation, apply these two corrections and you will obtain the true altitude. If it is a upper limb observation, after applying these two corrections, you have to subtract 30 minutes, can be considered as a upper limb correction to obtain the true altitude of the body. Now all this which I have explained is mentioned in this part here. You see, 30 minutes is to be subtracted from the altitude of the upper limb. So it is mentioned in this part here. If you have any doubts, you can just read this explanation given here and it will clarify how the table is to be used.
So this is clear, beta. Any doubt? Okay, very good. Let's proceed ahead now. We have seen the total correction for sun, stars, planet as well as moon.
Let's now move on to the next basic concept, which is the chronometer time ambiguity. Now, let's first understand what is this chronometer time ambiguity. The chronometer is a highly accurate clock which is set to the GMT, and whenever you take a site, you can obtain this GMT from the chronometer. Now the catch here, as you can see in the diagram, the chronometer has a 12-hour dial. The dial of the chronometer is only 12 hours, it's not 24 hour, so it gives you the time in 12-hour format. Now the clocks which we usually have in our homes also give us the 12-hour format time, but there is no ambiguity in those clocks because whatever time it shows, there are two possibilities. It could be AM or it could be PM. Let's say if the clock shows 1000 hours, it could be 10 AM or it could be 10 PM. Now at our home, we don't have any doubt because the position of the sun immediately tells us whether it is AM or PM. But the chronometer does not give you the time of the place where the ship is. The ship could be anywhere on Earth. It is giving you the time of the Greenwich meridian. So there is a possibility it could be 1000 hours or 10 o'clock in the AM, or it could be 2200 hours or 10 o'clock in the PM at Greenwich. So this is the 12-hour ambiguity which we have in the chronometer time. Now, how is this ambiguity resolved? Now, whenever the chronometer time is given to us in the question, with that, a AM PM indication is always given. Whether it is AM on the ship or it is PM on the ship, that indication is always given to you. And it makes sense because whenever you take a site, you will be aware of whether it is AM on board or PM on board. So we use this information to resolve the 12-hour ambiguity. So what we do is we write down both the possibilities for the GMT. The two possibilities, GMT1 and GMT2, are written down. Now we apply the longitude in time to the GMT. Longitude in time. What is this longitude in time? The longitude can be converted into time by dividing it with a factor of 15. So whatever longitude you have, if you divide that longitude by 15, it will give you the longitude in time. Now, from where do we obtain this factor of 15? We know there are total 360 degrees of longitude, and the Earth completes one round in 24 hours. So 360 degrees, one round completed in 24 hours. If you divide 360 by 24, you get this factor of 15. So in 1 hour, the Earth rotates by 15 degrees. So this is the factor which we have. Divide the longitude by 15 and you get the LIT. What is the use of this LIT? LIT can be used to convert GMT to LMT or LMT to GMT. So what do we mean by apply? It can be either added or subtracted. Like in this case, we have the GMT. We can add or subtract the LIT to get the LMT. Now, whether it should be added or it should be subtracted can be easily checked from the idiom. Longitude east, GMT least, longitude west, GMT best. So depending upon whether your longitude is east or west, you can find out whether the GMT will be least or GMT would be greater. And accordingly, you can use the plus and minus sign. Obviously, when the longitude is west, the GMT has to be best or greater. So you will obviously use a negative sign. And if the longitude is east, that means GMT has to be least. So it means you have to use a plus sign to obtain the LMT. Now, once you apply the LIT, you will have two options of LMT, LMT1 and LMT2. Now, these two options which you have obtained, check them with the AM/PM indication given in the question. So whatever LMT is correct as per the AM/PM indication, one of these LMTs will be in the AMRs, the second one will be in the PMRs. So you find out which is the correct LMT by using the AM/PM indication given in the question. Once the correct LMT is obtained, you can go back upwards and you can identify which was the correct GMT. That is the resolution of chronometer ambiguity. Nowadays, the practical use of chronometer has become redundant, and the change is evident in the questions which come in our papers also. Most of the questions, I would say 90% plus questions, are now based on GMT only, and you can straight away pick up the time without bothering about the any ambiguity, 12-hour ambiguity in the time. But it may find way in some of the questions somewhere, and if it comes using this method, you will be able to quickly and easily resolve the chronometer ambiguity and find out the correct GMT time.
So beta, all refreshed in the mind? Any doubts?
No, sir.
Okay, very good.
Now there could be a date ambiguity in some of the celestial navigation questions. What do I mean by date ambiguity? They may give you a particular date in the question, and they may not specify to you whether this date is the local date or the GMT date. There could be two possibilities. It could be local date or it could be the GMT date. If it is specified in the question, then there is no doubt. Whatever they have specified, if they have specified it is the GMT date, you use it as per GMT. If they specify it is the LMT date, you use it as LMT. There is no doubt at all. However, in some of the questions, if it is not specified or not mentioned whether the date given is the local date or the GMT date, what is to be done? So for all these cases, always remember the date given in the question is always the LMT date unless specified otherwise in the question. So whatever date is given to you, you will always consider it as your local date or LMT date unless they have specified exactly that this is GMT. Only in that case it is to be used as GMT. In all other cases, when it is not specified, it is to be used as a LMT date. Now, this is a very important statement and it will help you to resolve any doubt or any ambiguity which you may have in your mind related to the date of the question.
Beta, you can either note it down in your notebooks or you can take a screenshot and keep it safe on your device, whatever is convenient, so that you are able to refer to it whenever required.
Okay, sir. लिख लेते हैं, sir.
Yeah, write down, Beta. Let me know once you are done.
Okay, sir.
Okay, all right.